Process management and kill process. Armand Shahriarian. Process management. When you run a program, you initiate a process. You can think of a process as a dynamic, running instance of a program, which is static as it sits on a storage medium. Every running Linux system has dozens or hundreds of processes running at any given time. In most cases, you can expect the operating system to manage the processes in the best way. However, at times you may want to get yourself involved. As an example, you may want to check whether a process is running, since not all processes are running in the foreground. A foreground process is one that currently has the potential for the user to see and interact with, as compared with a background process, which a user wouldn't be able to interact with unless it was brought to the foreground and designed for user interaction. For example, just checking the number of processes running on an otherwise idle Kali Linux system, I discovered 141 processes. Out of that 141, only one was in the foreground. All others were services of some sort. To get a list of processes, you can use the ps command. The command all by itself doesn't get you much more than the list of processes that belong to the user running the program. Every process, just like files, has an owner and a group. The reason is that processes need to interact with the file system and other objects, and having an owner and a group is the way the operating system determines whether the process should be allowed access. In example 1 to 3, you can see what just running ps looks like. Example 1 to 3. Getting a process list. Root at rosebud #ps. What you see in example 1 to 3 is the identification number of the process, commonly known as the process ID, or PID, followed by the teletypewriter port the command was issued on, the amount of time spent in the processor, and finally the command. Most of the commands you will see have parameters you can append to the command line, and these will change the behavior of the program. Manual pages. Historically, the Unix manual has been available online, meaning directly on the machine. To get the documentation for any command, you would run the program man followed by the command you wanted the documentation for. These man pages have been formatted in a typesetting language called TROF. As a result, when you are reading the man page, it looks like it was formatted to be printed, which is essentially true. If you need help finding the relevant command line parameters to get the behavior you are looking for, you can use the man page to get the details. The man pages will also provide you with associated commands and information. The Unix manual was divided into sections, as follows: General commands, system calls, library functions, special files, file formats, games and screensavers, miscellanea, system administration commands and daemons. When the same keyword applies in several areas, such as open, you just specify which section you want. If you want the system call open, you use the command man to open. If you also need to know relevant commands, you can use the command apro pos, as in apropos open. You will get a list of all the relevant manual entries. Interestingly, AT&T Unix diverged a bit from BSD Unix. This has resulted in some command line parameter variations, depending on which Unix derivation you may have begun with. For more detailed process listings, including all of the processes belonging to all users, since without specifying, you get only processes belonging to your user, you might use either PSEA or PS auxiliary. Either will provide the complete list, though there will be differences in the details provided. The thing about using PS is that it's static, you run it once and get the list of processes. Another program can be used to watch the process list change in near real time. While it's possible to also get statistics like memory and processor usage from PS, with top, you don't have to ask for it. Running top will give you the list of processes, refreshed at regular intervals. You can see sample output in example 1 to 4. Example 1 to 4. Using top for process listings. In addition to providing a list of processes, the amount of memory they are using, the percentage of CPU being used, as well as other specifics, top shows details about the running system, which you will see at the top. Each time the display refreshes, the process list will rearrange, indicating which processes are consuming the most resources at the top. As you will note, top itself consumes some amount of resources, and you will often see it near the top of the process list. One of the important fields that you will see not only in top but also in PS is the PID. In addition to providing a way of clearly identifying one process from another, particularly when the name of the process is the same, it also provides a way of sending messages to the process. You will find two commands invaluable when you are managing processes. They are closely related, performing the same function, though offering slightly different capabilities. The first command is kill, which, perhaps unsurprisingly, can kill a running process. More specifically, it sends a signal to the process. The operating system will interact with processes by sending signals to them. Signals are one means of inter-process communication, IPC. The default signal for kill is the term signal, sig. Term, which means terminate, but if you specify a different signal, kill will send that signal instead. To send a different signal, you issue kill-#PID, where hashtag indicates the number that equates to the signal you intend to send, and PID is the process identifier number that you can find from using either PS or top. Signals. The signals for a system are provided in a C header file. The easiest way to get a list of all the signals with their numeric value as well as the mnemonic identifier for the signal is to run kill-l, as you can see here. Root at rosebud #kill-l. While a good number of signals are defined, you won't be using more than a handful. Commonly, when it comes to managing processes, the sigterm signal is most useful. That's the signal that kill and kill-al issue by default. When sigterm isn't adequate to get the process to stop, you might need to issue a stronger signal. When sigterm is sent, it's up to the process to handle the signal and exit. If the process is hung up, it may need additional help. Sigkill, signal number 9, will forcefully terminate the process without relying on the process itself to deal with it. The second program that you should become acquainted with is kill-al. The difference between kill and killal is that with killal you don't necessarily need the PID. Instead, you use the name of the process. This can be useful, especially when a parent may have spawned several child processes. If you want to kill all of them at the same time, you can use killal, and it will do the work of looking up the PIDs from the process table and issuing the appropriate signal to the process. Just as in the case of kill, killal will take a signal number to send to the process. If you need to forcefully kill all instances of the process named refox, for instance, you would use killal